coding tools. So it is important for you to know the tools that you're using to write your code. Those are coding tools. And one of the key part of that is a build system like Gradle, which takes all the input source, that is your sources, but also other things like images and those XML files and various other things, and it creates the final program. In Android's case, that would be an APK file. There's a lot of things that need to happen to make that work, but the rules for making that work are actually the same for all Android applications. So rather than you having to do that all by hand, there is an Android plugin for Gradle that will actually give you the code and tells you to say, okay, I want to, it will just build it all for you and knows how to do this correctly, and you just configure the bits that you need. But there's a lot of things going on underwater. An interesting thing of modern build systems that they are often able to automatically download your dependencies. That makes your development a little bit easier. There's some limitations to that in some contexts, but let's not go there. They also are, because they're basically automation tools, they know all the dependencies, so they are very easy. They're in a very good position to run your tests, because they have all the dependencies there. They might download, they know where they live, so they can easily run your test code. And indeed, build tools have quite often, or since many times, had the ability to say, okay, I rather than build my final build, I want to actually run the test code. And you can do that. In Gradle's case, it would be Gradle W check. And so there's also some other convenience operations that it can do. So it can actually also be used to run your application as a test version, because in the you don't want your end users have to use Gradle just to run your application. And you can also install it. Like for Android, there's a Gradle task called install debug that installs the debug APK on the single attached Android device with debugging enabled. So either an emulator or a real phone. But if there's two of them, it won't work, or it might install onto both. I haven't checked that. So the development tools that you're working with, so we have Android Studio IntelliJ. It's an editor. It does not run your code. It is just a very, very fancy, very featureful, glorified editor. And it provides a UI to many of the other things. So it is a user interface. It doesn't do the building of your code. It doesn't do the running. And your stuff does exist outside of Android Studio. Very important to realize. Your editor is just that, an editor. Those text files, you can open them with Notepad. Editing them with Notepad will work technically fine. It's just a pain in the ass because Notepad isn't really that powerful as a as a code editor, and it doesn't help you with indentation and stuff like that. But you can use any editor. There's a built-in editor in the GitHub interface. You could edit your code online in GitHub and actually make that work. So Git is your revision control system. I didn't put that here, but GitHub is a host for repositories. So it's a company owned by Microsoft now that hosts Git repositories, where you can host your repository in a central location so that you can do collaboration and sharing and all that stuff, rather than having to rely on having that on your local machine only. And it has also other kind of nice things, like a way of looking at your revision repository. Like I said, it has an actual editor built in for the quick edits and many other things. But Git is a revision control, and GitHub provides you the ability to have Git repositories. Gradle is our build system. Then we got ADB, or Android Debug Bridge. This is a tool that lives both on the phone or emulator as well as on your computer, and it allows interacting in a debugging fashion with your phones or emulator. So it allows the debugging to work, it allows the uploading of packages to work, etc. That's ADB. Then there's AAPT, which is the Android packaging tool. I forgot what the abbreviation is. Basically, it creates, there's a lot of things going on, but what it does, it packages all your images, it packages it transforms your class files into Dalvik bytecode, because Android doesn't quite use the JVM. It has its own virtual machine, but it translates from Java class files to its own virtual machines based instructions, and then packages that all up into one application, all done by the AAPT tool. Then there is, because Gradle is just a build system, it doesn't actually build anything. It delegates the actual compilation to either a Java compiler or a Kotlin compiler. In this case, Kotlin C. And it that creates your class files. Gradle kind of integrates that, and it tries to work with it smartly. One of the reasons that Gradle or that Android development uses so much memory is because that when Gradle runs a Kotlin compiler, it actually runs it in a persistent mode that keeps it in memory even if you're not using it, because it makes it much faster to start it up. So it makes building your code after you made a few changes very, very easy to do and very fast at the cost of memory. Memory from a developer perspective is cheap. From a company employing developers perspective, it's cheap. It's only an hour of developer time, so to speak, to give someone a decent amount of memory. And then the emulator, it's just a virtual phone. It works like a phone, but of course you can use it to test your applications in more variable circumstances than you would if you had a real phone. And of course, when you develop in a professional setting, you still want to test on actual phones as well, in particular because actual phones also come with actual implementation bugs all of their own. Samsung is very well known for that. Then we have debugging. So a key tool in the development is the debugger. In the end of the day, a debugger is just a tool that allows you to inspect the running of your program by allowing you to pause the execution, either through breakpoints or other things. So there's different kind of breakpoints, but the idea is you allow to pause the execution, then you can then query various elements of the state of your application. You can see, okay, is this what is expected? And it actually allows you to modify the state either by changing values directly or by running code. What it doesn't do is fix your code for you. Very common misconception I've seen in exams. No, debuggers do not fix your code. They help you interrogate what the state of your program is. So they are basically querying values is the steroid version of print lines. You can actually go in and look at it. It is also why often it's very helpful the toString function for your data, so that when you're debugging, you can actually see a textual representation of the state of your object. But even if there's no toString, you can actually define in the debugger your own toString functions for that particular type that get used instead. The debugger has a lot of powerful tools, and I won't go into this, but if you're interested, go and explore all the interesting things you can do with the debugger and become a debugging expert. The key parts, though, that you do need to know is the idea of being able to go step over, that goes to the next line of code, step into, that goes into the next function on this line, so it goes actually into function calls, where step over doesn't. IntelliJ or Android Studio has a smart step into, so you can say, okay, there's a number of functions on this line that I want to go into. Like, often you don't really want to go into a trivial getter. You know it's just a getter. It's not doing anything interesting. You're interested in the function that's being called with the value that was returned by the getter. So, and there are indeed also ways of filtering what it may or may not step into. Step out. Sometimes you say, okay, this function, yes, I know this is correct. I just want to go where this was called from. So there's step out. Of course, you have breakpoints. You can also, in Android Studio now, click on a line number, and that will bring you execute until you hit that line number, or another breakpoint. Breakpoints can be a line breakpoint. You can have function breakpoints, so anytime that function is called. You can also set breakpoints on exceptions or even on changes of values. Those are all more advanced. And you can use a breakpoint to even say, okay, automatically run a command like print some value and then even continue afterwards. A breakpoint doesn't actually, for the debugger, have to stop it in the UI. It stops the execution, but then if you say, okay, continue immediately, it will continue as fast as your computer can then do what it needs to do and continue. A cool trick there is also you can have a breakpoint conditionable on having hit another breakpoint, so you can basically hit a breakpoint only if you came from a certain path to get there. Because one of the problems with debugging is that you have a breakpoint that you're hitting a lot of false positives. So you're hitting the breakpoint 20 times before you get to the actual bug. Then for looking at the state, there is the watch expression, so you can specify expressions that you want to be evaluated. You can also look at the local variables that are visible here and there then.